Okay, so scientific notation, they gave you question 1. There were 6 numbers there that they gave in scientific notation. You had to write them in decimal notation. Right, so remember you look at the exponent of 10. So in the first case, that's 4. And that means that your comma must move 4 spaces. All right, so if you want to, you can actually show that. I'll just show you quickly. Let me just zoom in. I'll zoom out now again. You can physically do that, right? If you're writing this down, and you can go 1, 2, 3, 4, like that. So you're going to have a 32, and then you have 3 blank spaces. Those 3 spaces have to be zeros. Okay, so it's fine if you write it like that. Then we know if something doesn't look right. I don't want to make any mistakes. Okay. Also, guys, you don't have to space your numbers out. Remember, I did say that on Monday. You can just write 32 and 3 zeros. You don't have to like that. Fine. Any questions on number 1? Is that fine? Are you guys still busy? Okay, then for number 2, so I did ask you guys to rewrite the whole sentence, but it's obviously, yeah, there isn't enough space on my screen here. So just the sum in blue, that's what you had to change. So you were supposed to write the whole sentence, but then they gave you a number in decimal notation. You have to change it to scientific notation. So just mark the blue parts. So for that first one, it's 1,43 times 10 to the 9. That was for 2A. Then for 2B, 4,498 times 10 to the 9 as well. 2C was 3,793 times 10 to the 7. 2D was 7,15 times 10 to the 9. That's fine so far, guys. Any questions? I'm going to have to go to the next page now. So make sure that you mark those. Those 4. And that. Okay, then for E, it's over. Oh dear, it's frozen. Okay, there we go. For E, it was that 3,61 times 10 to the 8. F was 1,37 times 10 to the 10. And E and F. Right, then for G and H, there you can see the answer to G and H. G was 8 times 10 to the 10. And H was a whole bunch of numbers. What was that? 9,24376 times 10 to the 8. Any questions on that? Guys, that's it for scientific notation. All right, that's all you need to be able to do. You need to be able to go from scientific notation to decimal, or from decimal to scientific notation. Okay, that's all you need to be able to do. Are we trying to move on from this, guys? Do you have any other questions? I will post this whole note after this lesson. We've done it this. Right, you had some algebra that you had to do. Question 11. You just get that out, please. This was from that mixed algebra worksheet. Yeah. Okay, we'll just mark the first slide first. Remember, guys, I'm going to ask you to do some algebra practice every now and then, just so that you keep up to date with that. All right, so 11.1, 7x minus 2x, they are like terms, right? They're both x terms. So 7 minus 2 is 5. All right, so the answer there is just 5x. So 11.2, Now we are multiplying, guys. Remember when you're multiplying, you change the exponents. Okay, so we have two x's and then another x. We're multiplying them together. So that is going to be 3 altogether. So we write x to the 3. Okay, and then we had a y squared, so we need to write all of that. For 11.3, do we remember when we have an exponent inside a bracket and outside a bracket? You guys remember that you times those exponents together, right? So 3 times 2 is 6. So that is a to the 6. We are now dividing that by a. So that's I have 6 a's divided by 1a. How many a's will be left? 5. All right, so a to the 5 is the answer there. If you want to, you could have written this as a fraction, right? That might be a bit easier for you guys to just look at, I suppose. So you have 6 a's at the top, 1a at the bottom. If you cancel out the 1a at the bottom with one of the 6 a's at the top, you're going to be left with 1. Okay. 11.4 was a BODMAS question, guys. So when we get a BODMAS question, we circle the pluses and minuses, remember? Then we need to simplify all those terms before we can start adding and subtracting. So 2 times a is 2a, plus 3 times a is 3a squared. We take that plus again, and that is just an a. All right, now we have 3 separate terms, but they are all simplified. All right, there's no times and divide anymore, so now we can add them together. 2a and a are like terms. 2a plus a, I can add those together. That's 3a, and then we still have our plus 3a squared. Just a reminder that when you are marking this work, you need to make a cross, or you need to make a note of where you actually made the mistake. All right, so if you maybe, I don't know, if you added these together or something, you need to make some kind of notation or some kind of note of what you did wrong. Right? Don't just make a cross and then leave it open, because then you're going to keep making that same mistake. I'm not sure if you guys are marking properly, right? That's why I also work through it so that you can see all the steps, so you can find where you want. Okay, 11.5, thank you. Now here, guys, we have to divide before we can start adding, all right? So 4x squared divided by 2x. 4 divided by 2 is easy, right? That's just 2. Now you have an x squared, 2 x's at the top, 1 x at the bottom. Where do you have more x's? At the top. 1 more than at the bottom, right? So that's going to be x to the 1. At the bottom, you're just going to be left with a 1. You don't have to write that. Plus 6x squared. Guys, are these like terms? No. So that means that is your final answer. Remember? The answer is going to be 2x plus 6x squared. All right, you can't do anything after that. Okay, 11.6. Remember, guys, BODMAS brackets first. So if you can simplify what is in the brackets, if you can actually add them together, then you have to do that. And if we're looking at this first bracket, x squared and 2x squared, those are like terms. So you can add them together. Right, so that is what I did in my second line there. 1x squared plus 2x squared is 3x squared. Right, for this one, now what does it mean if I have a 3x written next to an x like that? I'm multiplying them, hey. So 3x times x is going to be 3x squared. Right, sorry, it's a 5, not a 3. My apologies. 5x squared again. Yeah, again, we have a 3 next to a 3x squared, so again, we must times it. And 3 times 3 is 9. Now, guys, now that I don't have any multiplication, I don't have any brackets left, it's just something plus something else, you need to ask yourself if they are like terms. 9x squared and 5x squared, are they like terms? Yes, hey, they're both x squared terms, so 9 plus 5 is 14. Okay, next one. This again was a BODMAS question. Guys, how do you recognize a BODMAS question? I keep saying it's a BODMAS question, but what makes a question a BODMAS question? Yes.
If there was the question and adding 4 to
Yeah, if all the operations are like mixed together, right? So like we have here, there's a times, there's a plus, there's another times and another plus. All right. So when I say it's a God maths question, I mean the operations are mixed together. So now we need to apply the correct order. So for that, we circle our pluses. And now wherever we have a term that has multiplication or division, whatever, we need to simplify that. So A times B is just AB. Plus 2B, that's perfect as it is. Plus B times 3A is going to be 3AB. Right? We just write them all next to each other in the correct order. Always the number first, and then alphabetical order after that. And then plus 5A. Right. Do I have any times now left here? Any multiplication symbols? No, no brackets, nothing. I'm just adding. All right. Now I need to look for like terms, guys. AB and 3AB. Those are like terms. 1AB plus 3AB is 4AB. All right. Then I have a 2B. Is there another term with just a B? No. Okay, so my answer there for that part is just plus 2B. And here I have a 3A. I don't have any other terms with just an A. Sorry, I keep thinking it looks like a 3 here for me. Sorry, it's 5A. All right, 5A. So plus 5A, that is in my answer. Okay, 11.8. Brackets first, guys. 3A plus 5A, they are like terms, so that is 8A. Leave brackets. 7B minus 5B, again, these are like terms, that is 2B. 8A divided by 4. 8 divided by 4 is just 2. Right? So remember that when we're working with numbers, we treat them as numbers. We don't change, we don't have any other rules now, all right? 8 divided by 4 is still 2, but now you must just make sure that you have that A there as well. Same thing here, 2 divided by 2 is just 1, but you have to have that B. And these are not like terms, so that is in your final answer, 2A plus B. Okay, we can't actually add those together. Then the last two are very similar. It was just for the first one, you have 5 A's at the top and 3 A's at the bottom. Where do you have more A's? At the top, how many more? 2, so your answer is A to the power of 2. Right, same thing for the last one, 11.10. 6 A's at the top, 2 at the bottom. Where do you have more? At the top, how many more? 4. Right, so your answer is A to the 4. Okay, we are doing something new today. So you can make a new heading, prime factors. Prime factors. Yeah, I've left a gap here because I'm going to write something here, so don't write this bottom part here. Just write your heading, please. Prime factors. Hey guys, what is a prime? What does that word mean? Does anyone know what's a prime number? One and a twelve. All right, so a prime number is a number that only has 2 factors. The first one is 1, and the second one is a 12. All right, so let's just add that. We do probably know that from primary school. Okay, so prime is a number with only 2 factors 1 and itself. So 1 and the number. Now we're all going to work with prime numbers for this whole lesson and tomorrow as well when we're marking. So we're just going to write down a few prime numbers. Let's start with the smallest prime number that exists. What do we think? What is that? Yes? 2. Okay, 2 is the first prime number. What other prime numbers do we have? Sorry, someone say something? Yes? 3, okay, what else? Let's keep going. 2, 3, and then 7, 5, and then 7. Go a little bit further. What next? Yes, Alex. 11, 13. Right, and then you can keep going. All right, but I'm just going to stop there for now. In the work we're going to do today, we are probably not going to go past 7 really. We're not going to use the numbers that are higher. But guys, if you just think of factors, right? 2, the only 2 numbers that can actually divide into 2 are 2 and 1. Right. The same with 3, the same with 5, the same with 11. The only 2 numbers that will divide into 11 are 11 and 1. Okay, so that makes those numbers primes. What is the word factors mean? A factor. What is a factor of something? How would you describe it first? Yes, okay, so I agree with what you're saying. I'm just going to change the wording slightly. It's a number that can divide into another number, right? So a factor. So if I say, for example, 5 is a factor of 25, that means that 5 can divide into 25, right? Does that make sense? Okay, so let me just write that there. So a factor is a number that can divide into another number. So today we are talking about prime factors, right? So that's just putting the 2 definitions that we've looked at now together. So a prime factor is a prime number. Can you guys help me please? A prime number that can divide into another number. All right. So I'm going to show you now how we're going to use this. Please write this down as your next. This is like, I would normally make a little bubble around this. Okay, so that's the type of heading that this is. Like a section heading. We're going to talk about factor ladders or a factor ladder. You might have done this in primary school, I'm not sure. But we're going to do that one now as an example together. Show you how a factor ladder works. And guys, this work is all supposed to be done without the use of a calculator. All right, so when we're going to divide now, we're going to look for factors and so on. We need to try and do it all without using a calculator. Okay, so guys, what I'm going to do is, this is now obviously the question, right? So I'll ask you in a piece like that. Write 1,260 as a product of its prime factors. Okay, so when you see a question like that, when they ask you to write something as a product of its prime factors, I want you to draw a straight line. My line might be too long, but it doesn't matter. And you are going to put the number. Suppose we can put it on the other side. Let me roll to put it on this side. The number that they are asking you to write as a product of its prime factors, you're going to put on the side of that line. Some textbooks, I think the textbook that we have put it on the other side of the line, but it doesn't matter. Now, guys, what did we say? Which number is the smallest prime number? 2. Do we think 2 will divide into 1,260? Is 2 a factor of 1,260? Yes, how do we know that? Just by looking at it. How do I know that 2 will be a factor of a number? Yep, it's an ends in an it ends in a 0, right? Remember, guys, any number ends in an even number. Then 2 can go into that number. Then it's a factor. All right, so what you're going to do now, guys, next to this number on the other side of the line, you're going to write 2. You're going to write the factor that you are now dividing this number by. Now we're actually going to do the division, guys. Now we are going to divide 1,260 by 2. What's left? We're going to write underneath the number. Okay. Now some of you might be able to just do this in your heads, just by thinking quickly, what is it divided by 2? But let me show you how to do it the long way, because it's not always going to just be an easy number divided by 2. Let's start from the front, guys. Can I divide 2 into 1? No. What about 12? What's 12 divided by 2? 6. So let's put a 6 under the 2. It's almost like we're doing long division in effect. All right, but it's not super long. Okay, what is 6 divided by 2? 3. And what is 0 divided by 2? 0. Okay, so you line them up like that. We're going to do lots of examples today, so if you're a bit confused, don't stress. Does it make sense, guys, that 1,260 divided by 2 is 650? Okay? All right. Now, can I divide 2 into 650 again? Yes, it starts at it ends, in an even number, right? So we're going to divide that by 2 again. So again, we're writing 2 on the side. What is 6 divided by 2? 3. What is 3 divided by 2? 1. 1.5, right? So 1, and then I'm left with a 1. Isn't that true? 3 divided by 2, right, is 1. But it's actually 1.5, so we have to put that there. Guys, if you want to think of it in an easier way, I probably would just say, what's 50 divided by 2, actually? What's 50 divided by 2? 15, hey, so you can just write the 15 like that. So if the whole carrying thing confuses you, you can just say 6 divided by 2 is 3. 3 divided by 2 is not a whole number, so let's see, what about 30 divided by 2? That is 15. Okay, so you can just write it like that. About is 2 going to go into 315? So now we look for the next prime number, right, which is 3. And guys, does anyone know how to check whether a number is divisible by 3? Then it is divisible by 3. Good. Let's write that on the side, guys. To check if a number is divisible by 3, and this is very useful, guys. If you remember this, it's going to save you some time trying to first figure out if it's divisible. Add the digits of the number. So by digits, I mean like the separate numbers that make up that number, right? So in this case, what are the digits? 3 and 105. Okay, so you would add those digits together. Then, if the answer, the sum, basically, when you add those digits together, if the answer is a multiple of 3, the number is divisible by 3. this specific check, yes. Yeah, this is a check specifically for 3. Yeah, there's 7 as well, but it is a bit different. I can't remember now exactly what it is, but I can research plus. Yeah, I did. You don't really need to use it. Yeah, there is a trick for 7 as well. I can't remember now. Okay, guys, 3 plus 1 is? 3 plus 1 is 4, plus 5 is 9. Is 9 a multiple of 3? Yes, so that means that this number is also a multiple of 3, it's also divisible by 3. So let's put a 3 there. What is 3 divided by 3? 1. Is 1 divisible by 3, guys? No. But 15? What's 15 divided by 3? 5. Can I now just put a 5 in? No, I must put a 0, 5 actually, hey? The answer when I'm saying 15 divided by 3 is 5, that answer has to be underneath the 5. Okay, so you must put a 0. What about 105? Let's see quickly. Is 105 divisible by 2? No. What about 3? Let's check. 1 plus 0 is 1, plus 5 is 6. Is 6 a multiple of 3? Yes. So this number is divisible by 3. Okay, what now about this? We are going to have to do a carrying over thing here. 1 divided by 3 is nothing. Okay, we can't do that. What about 10? 10 divided by 3. Can I do that? That's 3, but then what's left over, guys? What is the remainder if I say 10 divided by 3? It's going to be 1, hey? Because you have 3, 6, 9, but then 1 is left to make up 10. Okay, so my remainder there is 1. Now you're going to say, what is 15 divided by 3? 5. Okay, does 2 go into 35? No. What about 3? If I add these two numbers together, am I going to get a multiple of 3? 3 plus 5 is 8, right? So that doesn't work. So what's the next prime number, guys? 5. How do I know whether a number is divisible by 5? Yeah? It has to end with a 0 or a 5. Okay. This number does end in 5. So this is divisible by 5. So we put the 5 there. Now guys, this is an easy one. What's 35 divided by 5? 7. Now guys, which prime number is going to divide into 7? 7. What's left? What's 7 divided by 7? 1. Once you get to 1, guys, you are done dividing. Okay, so what am I going to, because what else am I going to do now? I'm going to say 1 and then 1 and then 1. I can keep on dividing by 1 forever, right? So once you get to your final answer of 1, you are done dividing. Okay, so stop once you get to 1. That is how you know that you are done. You have to start at the lowest factor. It's not a must, but it helps with the layout, but it's fine if you don't. There's normally 2 of those are the easiest ones to divide. Yes? I'm not sure if it's actually possible, but say you divide by 2 like twice, you know, but you have to go to the 3 like 3 twice. Can you go back to 2 again? So usually if you divide it by 2 and you can't divide by 2 anymore, then there won't be another 2 further down. Okay guys, we're not done yet, we've just done the division. What did this question say? Write 1260 as a product of its prime factors. What does the word product mean? Times. What did we do now? We divided, right? So when we now need to write this number as a product of its prime factors, we're going to have to say that 1260 is equal to all of these numbers multiplied together. Okay, I'm going to show you on the calculator that that is true. If we say 2 times 2 times 3 times 3 times 5 times 7, what do we get? 1,260. Okay, so that is what our final answer has to be, guys. We actually need to now write, therefore, 1,260 is equal to 2 times 2 times 3 times 3 times 5 times 7. It's not a must, but for what we're going to do next, all right, where we're going to use these products, it is best if you write them from smallest to largest, like I did now. Okay, so even if you decided up here you're going to divide by 5 first, and then by 2, and then by 7, and then by 3, just put them in the correct order when you're doing your product. Okay, so put the 2's and then the 3's and so on. Can I write 2 times 2 differently, guys?
Yeah.
Yes, I can. Yes, Alex? Yes, okay, so I can write it as 2 squared, yeah, and what next? Alex, yes? Right? 3 squared, hey, because there's only 2 of them. Yeah, no problem. Times 3 squared times 5 times 7. Okay, so guys, you are allowed to do that. If you have multiples of the same number, you can write them with exponents like that as well. Okay, any questions so far? I would like you to write down the following steps, and then we are going to use those steps, follow those steps. Let me just move that up in case some of you are still busy. So finding the HCF of 2 numbers, you might have done this kind of by inspection before. You just have 2 numbers that are quite small, finding the highest common factor. But we are going to work with numbers that are a bit bigger. All right, so we use specific steps to follow, so please copy those down. And then we're going to do an example. What does HCF stand for, guys? Highest common factor. You can just add that there if you want. HCF is highest common. Zoom in a little bit so that it's a bit bigger. There you go. Waiting for everyone to finish up. If you are ready, you can write your 540 and your 3150 and draw a line so long. We're going to do factor ladders for both of those numbers now. And guys, obviously you don't know how long the line is going to be at the start. It's fine if your line is too long, it's okay. And if it's too short, you can always just extend it if you need to. Usually the bigger the number, the longer the line. Right, guys, 540. Again, we're going to follow the exact same method that we did for the first one. We're going to start with the smallest prime number and work our way up just because it's easier that way. All right, you don't have to, but that's what I always do. Does 2 go into 540? Yes, hey? What is 5 divided by 2? 5 divided by 2 is 2. And then what's the remainder there? Because 2 times 2 is actually 4, right? So if I'm doing 5 divided by 2, I'm going to have a remainder of 1. Now we need to say what's 14 divided by 2? 7. And what is 0 divided by 2? 0. Guys, if you know that 540 divided by 2 is 270, you can just write it down. So you don't have to do the secret division thing. It's perfectly fine. Does 2 go into 270? Yes. Do we know what that is off by heart? 270 divided by 2. What's that? 135. Or you can say 2 divided by 2 is 1. 7 divided by 2 doesn't give you a whole number. So what about 70 divided by 2? That's 35. All right, you can do it like that. Does 2 go into 135? No. 3 does, hey? Let's check. 1 plus 3 is 4 plus 5 is 9. So 3 does go into 135. Some of you might see that it ends in a 5 and then you divide by 5 at the start. That's also fine. You'll get to the same factors at the end. Okay, let's do this quickly, guys. 1 divided by 3 is nothing. Right, what about 13 divided by 3? That's 4. Hey, if I'm going to 12. Okay, so 4, but I'm going to 12. That means I have a remainder of 1. So now I need to say 15 divided by 3 is what? 5. It's 45 divisible by 3. Let's see, what's 4 plus 5? 9. Hey, okay, so we can do 3 again. What is 45 divided by 3? Isn't it? What's 4 divided by 3? 1. And then we have a remainder of 1. What's 15 divided by 3? 5. It's 15. Okay. And if you don't know that off by heart, you can always go back to the like longer method. All right. So now you see I have to extend my line because I didn't draw it long enough. 15. Does 3 go into 15? Yes. What's 15 divided by 3? 5. Now what's the only prime number that's going to go into 5? 5. And then we end up with 1. And remember when you get to 1, that's the end of it. Okay, so I'm going to write my factors just now. Let's just quickly do the same thing for 3, 150. I'm going to make my line the same length. I might have to extend it a bit more. You can do that if you need to. So 3,150 ends on 0, which is an even number, so 2 will go into that, right? What is 3 divided by 2? 3 divided by 2 is 1, hey? But then that gets me to 2, so my remainder is going to be 1. Now we must have our wits about this, right? What's 11 divided by 2? 5, but that will get me to 10. So now again, I'm going to be left with a remainder of 1. 15 divided by 2? 7, but again, I'm left with a 1, a remainder of 1, because 7 times 2 is 14, right? And we did 15. So now 10 divided by 2 is going to be 5. 1575. Is that divisible by 2? Let's go into that. No. Let's check. What about 3? 1 plus 5 is 6. What's 6 plus 7? 13. Plus 5 is 18. Is 18 a multiple of 3? Yes. Okay. So this number is actually divisible by 3. 1 divided by 3? Nothing. That can't happen. What about 15 divided by 3? 5. 7 divided by 3? 2. And I have a remainder of 1, right? And now what is 15 divided by 3 again? 5. Okay, let's add those digits together and see if it gives me a multiple of 3. 5 plus 2 is 7, plus 5 is 12. All right, so 3 can go into this number again. 5 divided by 3 is 1, and I have a remainder of 2. Is that right? What about 22 divided by 3? What's that? 7, right? What is 20? What is 7 times 3? Is 21. Okay, so what's my remainder going to be? A 1. And now 15 divided by 3 is going to be 5 again. What is 1 plus 7? 8. 8 plus 5 is 13. Is 13 a multiple of 3? No. So now I can't divide by 3 anymore. Okay, and also not 2. It doesn't end on an even number. So now it's going to have to be 5, guys, which we can do because this number ends on a 5. 1 divided by 5 is nothing. What about 17 divided by 5? 3, but that will give me 15 actually, right? So my remainder here is going to be 2. And now what's 25 divided by 5? 5 again. Does 5 go into 35? Yes. What's 35 divided by 5? 7. So what is my last prime factor going to be here? 7. And 7 divided by 7 is 1. Okay, that's just step 1 done, guys. We've written both of these numbers, actually not even fully done. We've just done the factor ladders for each of them. All right. Now we're going to have to write both of these numbers as a product of their prime factors. So just underneath your factor ladders, we're going to write 540 is equal to, Now guys, in this case, when you're asked to find the HCF and the LCM will do next. But when you're asked to find the HCF, rather don't write them with exponents. Okay, we'll see now why I say that. Rather just write them as the separate numbers in a row. So I'm going to write 2 times 2. So we're listing all of these numbers on the the right hand side of the line. So 2 times 2 times 3 times 3 times 3 times 5. So that was the first number. 3,150. I'm just going to write it underneath this. It's best if you write them underneath each other, guys. I'm just going to write all of these numbers. 2 times 3 times 3 times 5 times 5 times 7. Okay, that's step 1 done. Step 2 is to identify all the common factors. Guys, remember what is an HCF? Highest common factor. So we have all the factors here now. We need to identify the common ones. And what I mean by that is the factors that appear in both of these products. So do we see that there is a 2 in both of them? Right? So I'm going to circle that. 2 is a common factor. Now 540 has a second 2, but does 3,150 also have a second 2? No. All right, so that second 2 there is not common with the other one. All right, so we're not going to circle the second 2. What about 3? Is there a 3 in both of them? Yes. Okay, so I'm going to have to do like a side thing like that. All right, those 2 3s are common. Is there a second 3 in both of them? Yes, so that is also common. All right, so we're grouping those 2 together as well. Is there a third 3 in both of them? No. What about 5? Is there a 5 in both of them? Yes. So guys, which factors are common? 2, 3, 3, and 5. We're just going to multiply those together, and that is the HCF. All right. So they're called HCF is equal to, we circled 1, 2 in both of them. So 1, 2 times, we circled 2 3s in both of them. So 2 3s, we're also going to multiply together. Times 1 5 in both of them. So we are multiplying by 5 as well. So guys, technically you're supposed to do this without the use of the calculator, all right? Sometimes the number is quite big, so then you can kind of check. But let's see if we can do this without using a calculator. Guys, what's 2 times 3? 6. And then 6 times 3 is going to give us 18. And can we do 18 times 5? Is that 90? Yes. Yes. All right, guys, does that make sense? So you do your factor ladders, all right? You list your factors underneath each other. You circle the ones that are common, and then from there you times those ones. Now, guys, it may actually have been a bit easier to see which ones are common if you wrote it like this. You don't have to rewrite this now, but I just want to show you quickly. If you like line them up. So if I'm doing 2 times 2 times 3 times 3 times 3 times 5, sorry, I'll move that back just now. And then the other one was 3 150 equals. So now if I make sure that I have a 2 here in line with that one, then for my 3 150, I didn't have another 2, so you can leave that kind of open. Times, there were 2 3s like that. We didn't have a third 3, we have 2 5s, so then you can do a 5 times 5 times 7, like that. Right, then you can just kind of group them based on the ones that are like in line. Right, maybe that's, I don't know, it's up to you if you want to write it like that. You don't have to, you can also just do the circling. Okay, whatever works for you. When we're going to find the LCM, though, we are going to have to write it out like this, but I think we'll do that tomorrow. I don't want to confuse that now. We're going to just write the steps down for me now, though, but we're not going to do an example. Right, guys, any questions on HCF? Are we all right? Okay, you are going to just write down the steps for finding the LCM for me now. And then we'll practice that tomorrow. And when you are done copying down the steps, you can pack up and then we'll just wait for assembly to start. There's still 9 minutes left.